Hello, and thank you all for joining us in this webinar on continuous delivery and DevOps acceleration. My name is Dori Eksterman, and I'm IncrediBuild CTO. In this webinar, we are going to review a few topics. We are going to discuss the benefits of continuous delivery and the challenges we have there, especially in terms of performance. We are going to review a few solutions to accelerate continuous delivery, and we also are going to show a live demo of how this can be achieved. So the benefits of continuous delivery are something that's widely known today, and more companies and organizations are moving to continuous delivery and DevOps due to these benefits. Major benefits of continuous delivery involve reducing the pain, risk, and time it takes to release a new version. When it takes you smaller time to release a new version, and you can release version in less risk and more safety, it means that you deliver frequently and you become more competitive and you become more agile in your development. This allows you to get better products to the market and sooner than before. One of the problems that we have in continuous delivery is that it's time consuming. It's time consuming both from the stage of developing the continuous delivery cycle itself. It requires you to put a lot of efforts in automation, especially in test automation, but it's also costly in terms of performance. It usually, once you have a large build, a large product, it takes a long time to execute the entire continuous delivery cycle. It usually involves compilation, testing, a variety of tests, a lot of code analysis, maybe sometimes packaging. If you want to test several packages, you can multiply the amount of tests by the number of packages that you have and you want to build. And there are also a lot of companies and products that need to have other aspects in their continuous delivery cycles, whether it's asset building, simulations, rendering, and other activities. The challenges in terms of performance in continuous delivery, first and foremost, is to allow the developer to get as fast as possible feedback regarding the build that it just initiated, the cycle that it just initiated. In Agile, we are speaking about less than 5-minute cycle, and 5-minute cycle, I believe it's quite the top limit of what you want to have. If you have more than that, developers will start thinking twice before they commit their source code. We have, I'm speaking with customers that have something like 30 minutes release cycle, continuous delivery cycle. And in these scenarios, developers are usually only committing their code once or twice a day. They try to schedule it for lunchtime or after they finish their work. And it's actually not enough, especially if this build suddenly fail after 25 minutes, then now they need to re-execute it, and it takes all the edge out of the development process. So we want to keep the fastest possible feedback to developers, but we don't want to compromise. We want to do more. And one of the things that you need to keep in mind that even if your project is now a relatively small, projects only grow larger. And if you have continuous delivery as part of your project, then you'll want to add more and more tests as you enhance your continuous delivery cycle. Once you have enough tests and you have enough automation, probably your build time and cycle will increase. And you also want to do more. Maybe you want to do code analysis. Maybe you want to test a few more packages that are part of your product. And a variety of other tests, maybe not only unit testing or stress tests, maybe some smoke tests and API tests and regression and some others that will make your continuous delivery cycle much safer. Another aspect is that although we want all this performance gain, we want to make it financially feasible. So we don't want to purchase too many expensive hardware or machines, and we also want to have a reasonable amount of time dedicated to integrating this kind of performance acceleration for our continuous delivery cycle, and the maintenance should be minimal as well. So this is strongly related to continuous delivery. Moore's law is going to die soon. So the law that every 2 years or 3 years the speed increase double, it's going to end soon. And companies, the increasing clock speed really reduced just long ago. And the way that companies handled it is by introducing the multi-core technology. So as you can see here, more and more machines, and you can probably feel it yourself, more and more machine, more and more cores. And luckily for us, continuous delivery tasks can actually benefit from this kind of technology. Just step back. What we want to make sure is that our continuous integration and continuous delivery will be able to take benefit of this multi-core technology that the market is going through. So instead of doing things in a linear way, in a sequential manner, we want our tools and our continuous delivery cycles to be able to use as much cores as possible, and to be able to be parallel as much as possible. So luckily for us, continuous delivery is mostly parallel. A lot of tasks inside continuous delivery are parallel. If we're speaking about compilation, if we're speaking about testing and code analysis, these are highly parallel tasks. They are loosely interdependent. For example, if you're running 1,000 unit tests, usually these unit tests do not depend upon one upon another, and you can potentially execute all 1,000 of them in parallel. These are usually multi-process, which is nice when we're speaking about distributed computing, and we'll go into that later on. And there's usually no inter-process communication, so this is also something that allows us to offload tasks to other machines if needed. We are going to work here on a sample of a continuous delivery cycle that in this scenario, when working on a single core, takes, as you can see here, 7.5 hours, which is a very long time, and it's not quite continuous delivery as we want it. So, as we said before, continuous delivery is really an ideal candidate for multi-core technologies. It's time consuming, we really want to make it faster, so if we'll add more cores, it will get faster. It's usually CPU intensive task, whether it's testing, compilation, code analysis, packaging. This is less I/O, mostly CPU, and it's time sensitive and highly parallel. So we can use multi-core technologies to accelerate this. So if we're speaking about coming from 1 core to 4 cores, we already reduced our build time from 7.5 hours to just a little bit above 2 hours. Of course, if we purchase an HPC machine with 20 cores, we'll be able to further reduce the build time, the continuous delivery cycle, to 17 minutes and 30 seconds, which is very nice, but there are some limitations to that. So one of the pro of going HPC and buy very expensive build server machines is the ease of implementation. I don't need to do anything if my continuous delivery cycle already support parallelization. I can simply purchase more and more expensive HPC machine going up to 64 cores, and that's it. I don't need to do much more than that. The cons are very straightforward. One of them is it's very costly. It costs a lot of money to purchase a 64 cores HPC machine. It's not scalable. So if you consider 64 cores a very scalable solution, that's only because you probably have some small projects. I'm speaking with customers whose continuous delivery cycle can take more than a day. So even if with a 64 core machine, it will still take several good hours to run the entire continuous delivery. They need something like 600 cores and not 64 cores. And you also have another problem that once you have development teams with several people, let's say 50 people or 30 people, they will probably execute multiple times a day their build, their continuous delivery cycle. And it means that if you only have a single HPC machine, the third developer that will execute his build will need to wait for his turn in the queue. So if we spoke about the 17.5 minutes build, the third developer will need to wait more than 45 minutes till he gets a response, and it can be a negative response, whether his build was successful or not, his commit was successful or not. So from HPC, we are going to a cluster solution. The way to handle this queue issue is to cluster a few build server machines together. We have a lot of continuous delivery, continuous integration tools that allows us to do that, whether Jenkins or TFS and a variety of others as well. So you can have several nodes or slaves or whatever the terminology is according to the continuous delivery tool. And if you have 3 developers queuing builds, each build can go to a different machine, and then the third developer that just initiated the build will still wait no longer than 17.5 minutes, unless you have more and more developers queuing builds, and then you'll still have queues on your machine. So it's nice, it's scalable. You can add more and more machines as your team grows, but it's still limited. You are still limited in the duration of the response you can provide to the developer. So if you are speaking about 10 machines with 20 cores each, you will still be limited to a response of 17.5 minutes. It's costly. Purchasing something like 10 machines, 20 core each is a costly solution. It costs both in cash and in maintenance of IT and build infrastructure, build tools, environments, etc. So it requires dedicated hardware. And the sad thing is that when you are at peak times, even if you purchase 10 machines, they will usually be good for you for day to day. But if you have a large team of 50 developers and you are at peak time before releases, you will probably want to have more. And developers will do more commits and will want to test their code more. And you will want to run more tests and more code analysis in order to make sure that your release is going well and that your product is stable enough. When you're not at peak times and your resources won't be enough for you in that phase, you will, in a day-to-day activity, probably half of these build server machines will simply remain idle, and you won't gain any benefit from purchasing them. So this is maybe not the best solution you can get. Distributed computing is something that's been around for several years now. It started even before the 80s. And the benefits are very straightforward. In your organization, you probably have hundreds and thousands of cores just sitting idle. So you have people from marketing, people from sales, and even developers using only 10%, 20% of their 4 or 8 core machine. Why not use these idle CPU cycles to accelerate tasks that you have as part of your continuous delivery cycle? You already own these cores, you already maintain them by IT, and you're already paying for the electricity and for the cooling and for everything, for the space. So the logical thing is to use these things you already invest in. They are connected through a low latency LAN when you're working from the office. And if you are at peak time and you only have 500 cores in your entire organization, and before version release you want to have more, you can simply scale to the public cloud and get some cores out of the public cloud as well. So distributed computing seems like a logical solution when you want to do more in less time and you have parallel execution, which is feasible. So this is an example of the same continuous delivery cycle running on a distributed computing environment with utilizing 100 cores. So as you can see, this build time was reduced from 17.5 minutes to something like 3.5 minutes. So as we discussed, if we take a cluster solution, the build will run for 2 hours, and the developer will need to wait 2 hours, even if you have several machines. But with a distributed computing solution, you'll be every build server machine will be able to scale and use not only the cores that resides on the build server machine, but also other cores that you have in your organization on public cloud. And if you use 100 cores, which is not a lot when we're speaking about distributed solutions, you'll reduce your build time to 3.5 minutes, and that's the amount of time you want developer to wait for his feedback. So some drawbacks regarding distributed computing, but it really depends on the solution. If we're speaking about a generic solution, there are a lot of general solutions for distributed computing in the market, but they usually require integration. You need to integrate into this solution into their proprietary API. And then once you do that, you'll be locked to this infrastructure and platform. Because you already invested a lot of time in integrating with their proprietary API. You need to do the integration for every aspect of your continuous delivery cycle, whether you need to integrate it with the continuous delivery tool itself. In order to accelerate the compilation, you need to have integration there for the testing. For every aspect of the continuous delivery cycle that you want to use distributed computing, you'll need to integrate it. It will require intimate knowledge of your execution and of your tasks, because you need to know in which scenarios files need to be transferred from one place to another, when and where to take files back from the remote nodes to your local machine, and a lot of other stuff that you need to be aware of once you do such a tight integration. The maintenance and management of this kind of solution is also expensive, and it takes a considerable amount of time to do that. There are specific solutions for specific problems. For example, SATI at Home is a project that goes on for several decades now. Try to analyze extraterrestrial noises and try to find out if there is life in space. But this is a distributed computing solution for a specific, very specific problem. And you want to have something that it's more general, and you'll be able to use it for a variety of problems or things that you want to accelerate as part of your continuous delivery. IncrediBuild has a very unique approach to distributed computing. IncrediBuild was developed with focus on development teams, on accelerating development tools, and continuous delivery in the most possible, easiest way for the developer and user to use it. So it's a kind of container Docker solution. We are able to distribute the process from a single machine to a remote machine without you needing to have anything on the remote machine. You don't need to pre-install the build scripts or the tool chain or your source code, nothing at all. IncrediBuild will virtualize the process on the fly on the remote machine, and will bring back everything that the process generates, whether std out, std error, or files, to the local machine that initiated the process, or the build server that initiated the process. It can be easily extended to support any multi-process execution, even if it's not part of the default tools that comes with the product. It allows you to use the idle CPU cycles you already own in your network, in your organization. You can use machines from people from sales or from marketing or from development, or any machine that you have in your organization. IncrediBuild will be able to use the idle CPU cycles you have on this machine and memory in order to transform every build server or every developer workstation into a virtual HPC machine, high performance computing machine, that will essentially scale from 8 core, for example, or 16 cores to something like 800 cores. One of the main benefits is that it's command line based, so it can be easily integrated into any continuous delivery or continuous integration tool that allows you to execute commands, command line. So customers that are using IncrediBuild are using it in a variety of continuous delivery tool, whether Jenkins, TFS, and a bunch of other very popular continuous delivery tool, and they simply take their command, whether it's a compilation command or test command, and wrap it with IncrediBuild. That's the only integration they need to do inside their build script in order to use IncrediBuild and tell IncrediBuild, listen, I now want to compile or test, and I want to use as many cores as I have in my entire organization. And that's exactly what IncrediBuild will do. It will aggregate all the cores in your organization, as long as IncrediBuild is installed on these machines, and will allow your build server to use them in a seamless manner. From your perspective, it's really as if your build server just transformed from a 30-core machine into a 300-core machine. So the way that IncrediBuild solves this problem of steps that takes long time inside your continuous delivery cycle is by reducing every single step inside this that can be reduced in terms of performance. So if we're speaking about compilation, instead of running 50 minutes compilation, we'll run it 10 times faster. We'll run the testing 10 times faster, etc. And that's the way we will reduce the entire continuous delivery cycle. Let's see a demo of that. What you're seeing here is a virtual machine in the cloud. This specific instance is provisioned in the Azure, Microsoft Azure public cloud. And as you can see here, we are going to demonstrate TFS, which is a Microsoft ALM and continuous delivery tool, Team Foundation server. TFS is very similar to Jenkins, TeamCity, and other continuous delivery tool. But you can work with it from inside your Visual Studio instance as a developer. You can queue build, you can queue items, etc. What we're going to show here is a workflow that we are going to accelerate part of it, the compilation part, with IncrediBuild using distributed computing. So I have an instance in Azure, and I have various other instances I provisioned. We can look at it here. There is the Azure portal. One second. Let's take a look. So this is the Azure portal, and as you can see, I have several instances running in the Azure portal. I can take a look at the virtual machines that I have here. I have 4 instances that Agent 1 is the one that I'm connected to, will be able to distribute tasks to. So we'll go back to the instance, to the Azure instance. So as you can see here, I have Visual Studio, and this is the build, actually this is the workflow I would like to execute. So every solution has a workflow attached to it, it's called build definition in TFS. And if I right click here on this specific solution, I can queue a new build telling the TFS server, build server, to execute the workflow, execute the build script. I'll just queue a new build, and while I'm doing that, and the build will start executing, we'll take a look at the way that TFS works in terms of build script. So this is the repository, and as you can see, I have several templates in the repository. Each template is kind of build script that is being written using a XAML, which is an XML file that describes for TFS how to execute my continuous delivery process. And this XML file also has a graphical representation. So if you can take a look here, and you can see every box here is a step that contains several steps inside it, and you can actually design the workflow of your build process. This specific box represents the compilation. If I'll right click here and go to properties, I'll be able to see exactly what it is that I'm executing. So I have the file name, which is the executable that I'm executing. If I'll take a look here, you can see that we're executing the IncrediBuild console executable, which is the executable to run when you want to execute something with IncrediBuild. And then we have some arguments that we pass to this command, and these arguments include the project I want to build, which here is all the project and the configuration and the task that I want to do, which is rebuilding the entire solution. So usually what I'll have here is an MS-build command. The only thing I needed to do in order to use IncrediBuild instead of MS-build is to use the IncrediBuild executable with the correct parameters. So we can take a look here and see the build that finished. And if I'll go to the IncrediBuild build monitor, just I'll close this one and I'll open all the build history, all the builds that were executed with IncrediBuild, and I can choose the last one and take a look at the way that it was executed. So as you can see here, this is the machine that I'm currently on, the Agent 1, and you can see that Agent 1 distributed compilation tasks to various other agents I have in the network. So from the cloud instance, it has 2 additional agents in the network which it distributed tasks to. So you can see here a lot of compilation tasks being executed on these remote machines, and all the output was brought back, including the std out and all the OBJ files and everything that is part of the build execution. So you can probably imagine that the build takes much faster when working on 16 cores than on 4 cores, and in the same manner we can simply provision additional machines to further reduce our compilation time, and I can do the same thing for any other step that I have as part of my continuous delivery cycle, whether it's testing or code analysis or anything else that is multi-process, parallel, and can be accelerated using distributed computing. Let's go back to the slideshow. So we have a lot of customers doing this kind of acceleration with IncrediBuild. We'll take a look at a few examples. Forza, which is a very known game studios that build, it's Turn 10 that built the Forza, famous Forza game. They used IncrediBuild to accelerate various tasks inside their continuous delivery cycle, whether it's QA script and rendering and data conversion. For example, in compilation, they reduced their compilation time from 60 minutes to 8 minutes, and they also accelerated their conversion of Autodesk 3D Studio Max rendering output to their own proprietary format, which reduced their time from 6 hours to 20 minutes, which is very, very meaningful when you're speaking about delivery cycle. Waiting a 6 hour and another 60 minutes for compilation, 7 hours, it's a long time to wait for a continuous delivery cycle. Reducing this to 28 minutes is a large benefit. And a variety of other companies are doing what they need to do with IncrediBuild. They need to accelerate their own stuff. So whether it's cold build, asset build, here in Celebrite, packaging is highly accelerated. Retalix, which is a division of NCR, highly accelerated their 30,000 unit tests and integration tests with IncrediBuild. And Lucis accelerated the QA cycle 10 times faster, more or less. I've showed you one way to integrate IncrediBuild into build script. You can simply replace your original build command with IncrediBuild build command, but you can also wrap your build command with IncrediBuild. So for example, if you have an MS build command, the only thing you need to do in order to use IncrediBuild to accelerate it is to wrap it with build console/command and pass your original command line. The only thing you need to do in addition is to pass to the build tool, MS Build in this instance, a flag that tells MS Build to execute a lot of tasks in parallel. So all the popular build tools, modern build tools, have this kind of flag. This flag allows them to use and take benefit of the multi-core technology that's very common today. So usually when I run this specific build command without IncrediBuild, I will usually have the /m equivalent to the number of cores I have in my local machine. So for example, 4 cores. this will instruct MS-Build that I only have 4 cores on my machine, so it should execute as much as 4 tasks in parallel. When I'm running with IncrediBuild, I would like to tell MS-Build that I have 200 cores or 400 cores or 1000 cores on my build server, and IncrediBuild will take hold of the queue that MS-Build generates of the tasks and will simply distribute the tasks that it can to remote machines across the network. Another example is using make. So usually the make command will be make.exe, and the only thing I need to do here is wrap the make command with build console/command, pass the make argument, the make command line, and -j, which is again the multi-job value that make received, with 1000, telling make that I wanted to execute as many as 1000 tasks in parallel. IncrediBuild support a lot of tools out of the box and in a lot of fields. All of these that you can see here can be accelerated with IncrediBuild. They are usually parallel, multi-process. You have a lot of them, and there is no reason why not distributing them to cores across the network. So it can be compilation, code analysis, various tests, whether regression, unit tests, stress tests, integration, simulation packaging, and a lot of other things. IncrediBuild comes with a default set of tools that it supports out of the box, so you don't need to do anything in order to integrate it with IncrediBuild. You simply need to wrap the command, the original command, with IncrediBuild, as I showed you before. But if you have your own kind of processes that you want to accelerate, homegrown tasks, homegrown tools, or any other commercial product that IncrediBuild currently does not support out of the box using its default profile, you can extend IncrediBuild's functionality by simply writing a small configuration file in XML describing to IncrediBuild how you want IncrediBuild to relate to the processes being executed as part of your execution. So in this example, I have a simulation application which invokes 1000 simulation processes. In order to integrate this process with IncrediBuild, what I need to do is tell IncrediBuild the simulation application is the one that invokes tasks that I want to distribute. So I will say that allow intercept true. This is what tells IncrediBuild to intercept all tasks the simulation application executes. And I also want to tell IncrediBuild that once a simulation process executes, we want IncrediBuild to execute it remotely. So we describe it as allow remote. And then instead of simply executing using simulation application.exe, which is the regular way I execute my simulation application, I'll again wrap it with IncrediBuild's command, id console/command, and also pass the configuration file path to the IncrediBuild command. Once I'll do that, IncrediBuild will execute the simulation application, and every time the simulation application will execute a simulation process, IncrediBuild will take this process, and instead of executing it on a local machine, it will execute it on a remote machine. And thus you'll be able to execute a lot of simulation processes in parallel, benefiting from the hundreds or thousands of core you already have in your local network. As I said before, IncrediBuild comes predefined with a set of tools, set of very common and popular tools, whether build tools, tools for unit testing, for code analysis, a large set of compilers, and other tools as well. And using command line interface, as we've seen before in TFS, you can easily integrate IncrediBuild in any continuous delivery tool that supports command line execution. So to summarize, the first thing you need to do if you want to start accelerating your continuous delivery and plan for accelerating your continuous delivery is first to identify the tasks that can benefit from multi-core technology. For example, getting the last version from Git or copying files is usually a sequential task, a sequential process. So if it takes 90% of your continuous delivery cycle, you won't be able to get much benefit out of IncrediBuild or out of anything that allows you to distribute tasks or to run things in parallel. So you want to make sure that as much of your continuous delivery cycle is parallel and can be parallel in order for you to be able to benefit from multi-core technology. So you need to analyze whether your parallel execution can benefit from dozens or hundreds of cores. If they can only benefit from 4 cores, again, you should only use your local build server cores. But if you have tasks, or if you can bring your tasks, especially the time-consuming one, to be able to execute in parallel, that's the way you progress. And if you currently use a build tool that does not support parallel execution, or you have your own homegrown tool, try and make and see how you can either change the tool to a tool that supports multi-core execution, or change your code if it's a homegrown code in order for you to be able to do that as well. Once you do that and you see that you can potentially execute a lot of tasks in parallel in your continuous delivery cycle, the next thing would be to choose the distributed computing environment that is good for you. And then once you do that and you see that your build time was reduced from 30 minutes to something like 3 minutes, that's the phase where you can improve your continuous delivery cycle. Because when you had it in 30 minutes, I believe that you wouldn't want to add some more tests or code analysis or other phases to your continuous delivery, although they will make your continuous delivery cycle faster, safer, and much more robust. Now that your continuous delivery takes 3 minutes, you can add more things, more elements to your continuous delivery process and further improve your build, release, deploy cycle. So thank you very much. That's the time for any questions if you have any. My name again was Dori Exterman, and I was happy to be here. Let's take a look at the questions. Okay, I see here one question asking whether IncrediBuild can accelerate homegrown continuous delivery software. The question is essentially yes. If your homegrown solution supports command line execution, I believe that it does, because that's the way you probably execute your compilation or your tests. As I showed before, the only thing you need to do is wrap your original command line with IncrediBuild inside your continuous delivery cycle, and IncrediBuild will take this specific execution, whether compilation, tests, or others, and distribute it to remote machines across the network. Actually, we ran a survey not long ago, and we found out that the majority of our customers are still using homegrown continuous delivery tools that they developed in-house. Next in line was Jenkins, but still 70% of the customers are using their own homegrown tools, and they use IncrediBuild to accelerate their cycles. Another question here is whether IncrediBuild can be used to accelerate batch scripts, QA batch scripts. So from IncrediBuild's perspective, a batch file is simply an executable, like any other executable we've shown before, like the simulation application executable. So you can simply wrap this command batch file with IncrediBuild, and IncrediBuild will run in parallel and using remote cores the task that you have inside your batch script. IncrediBuild has a variety of integration interfaces. I've shown you only one of them. We have 2 others. And we have one that's specifically designed for batch script as well. It's called the submission interface. So you can either use the submission interface and you can look into it in our help file, or use the interface that I showed you before. Okay, that's all for the questions. So thank you again, and I hope to see you soon in the next webinar we are going to have. Goodbye.